Okay, my friends, let's start this k-means clustering implementation together. All right, so in the previous tutorial, I think I asked you to try to implement the first phase on your own. I'm talking, of course, about data preprocessing, which indeed seems to be very easy here because we only have to import the libraries and the dataset. And it is even easier because we have, well, our data preprocessing template. So the only thing that we have to do is just to copy-paste these first two cells here, and then, well, let's see what we have to change, what we should change to prepare our k-means algorithm. All right, so we're going to start by importing the libraries. That's inevitable. We should use the three of these libraries, maybe not NumPy, but definitely Matplotlib and Pandas. But anyway, let's just import them all so that we can make sure we have everything. And now let's import the dataset, and I'm going to copy that cell right here and paste it in a new code cell right here. All right, great. So now let's see what we have to change. Well, we don't have to change anything here because we anyway want to have these three libraries. And now when importing the dataset, well, the first thing, of course, is to change the name of the dataset here. That was the template name of the dataset. And we need to replace this now by the name of the dataset, which is mul_customers.csv. So let's do this, mul_customers.csv. And now that's when things start to get interesting. What did you do with these two entities? You know, X, the matrix of features, and Y, the dependent variable vector. Well, let's start with the matrix of features. The matrix of features here takes exactly all the columns except the last one. Remember what we did here with that trick to go from the range of 0, index 0, up to -1, and -1 is excluded. Therefore, we exclude the last column. But let's have a look at our dataset again, and actually let's import it here in order to have a look at it in the notebook. So right now it's connecting to runtime. I'm going to show you the dataset, and well, we'll see if we have to exclude that last column, right? So there we go. Let's upload it. So as usual, I put the machine learning AZ folder on my desktop. So we're going to go this time into part 4 clustering, then section 24 k-means clustering. My friends, we're making great progress. That's great. We're almost halfway there. And then we're going to go to Python. And finally, we're going to select and open the mul_customers.csv file. All right. And now let's double click it to have a look at it. It's simpler if it is in our notebook. All right, so the question is, do we need to change anything here when creating that matrix of features? Well, obviously, as we explained in the intuition lecture and in the previous tutorial, there is not a dependent variable a priori when doing clustering, and especially k-means. So here, the last column of this dataset, the spanning score, is not the dependent variable. It is actually a feature which we will use as part of the other features to identify some patterns in the data. And these patterns, I remind, are actually clusters or segments of data which will be gathered by similarities. All right. So that was an essential thing to understand, and therefore I hope you did not exclude the last column here. So the first thing we would do is to just remove this -1 in order to take indeed all the columns. All right. So if you already did that, I'm really proud of you. You did an amazing job. But now I want to improve this actually. Let's remember that the goal here is to, as we said, identify some patterns or clusters in the data by using all of these features here. But do you think that among these features, some of them, well, won't actually help much identifying these patterns? And well, the answer to that question is, of course, the customer ID. The customer ID column is just giving an ID to each of the customers and therefore has literally no impact on whatever dependent variable we will create in the future. Because I remind that the process of the k-means algorithm is that indeed it identifies some clusters in the data, but also technically it will create a new dependent variable where the values will be actually the clusters themselves. And therefore, since the customer ID is just some identification of the customers, well, we know for sure that it is totally irrelevant here. So we can actually exclude this column. Okay, so now that being said, what else can we do? Well, all the rest, the jar, the age, the annual income, and the spending score, seem totally relevant in order to identify some patterns in the data. And so now from that point, I didn't expect you to do much more to solve this exercise, except of course the final modification we'll do for that row, but we'll come to that later. However, now for the matrix of features, the columns that I want to keep in order to identify these patterns will only be actually annual income and spending score. And that's only for one particular reason, which is mainly for teaching purposes. Well, at the end of this implementation, I indeed want to visualize with you the clusters, the clusters identified by the k-means algorithm. But in order to visualize them, well, we actually need a two-dimensional plot, right? We need a 2D plot where on the x-axis we will have one feature and on the y-axis we'll have another feature. And therefore, in order to visualize the clusters, we exactly need two features. Otherwise, if we get, for example, 3 or 4 features, it will be very hard to visualize the clusters because, well, we need one axis per feature. It would be kind of possible in 3 dimensions, but we'll have a much nicer graph in 2D. And therefore, and once again, that's not what I expect you to do, we're only going to keep these 2 columns, the annual income and the spending score, to identify our clusters. And of course, I made this data set so that we can indeed find some very interesting clusters for the mall, which is trying to, of course, get some insights from their customers. And therefore, now the exercise, and you can press pause on the video to complete it, is to change something here in the matrix of features X in order to select only the annual income and the spending score among the features, among the variables, which we will use to identify the patterns. So please press pause and I'll give you the solution in a few seconds. All right, great. Let's do this together now. So the exercise was to only select the annual income column and the spending score column in our matrix of features X. So let's do this. And well, this time, since we're selecting, 2 particular columns, well, we won't use a range to do this. There is actually a better method. We will select these columns, the indexes of these columns, into a pair of square brackets. And that's the other way to select some columns with, this iLoc function. It is with this pair of square brackets inside which you can include the indexes of the columns you want to select. And so now the question is, what are these indexes? Well, let's see. Remember that indexes in Python start from 0. So customer ID here has index 0, jar has index 1, age has index 2, annual income has index 3, and spending score has index 4. And therefore, here in this pair of square brackets, well, we just have to input 3 and then comma and 4. In order to select several indexes, you have to separate them with a comma. And that's it. That's how you create this matrix of features, selecting some specific columns with which you will learn some patterns in the data to identify some clusters through the k-means algorithm. Great, so now that's done for the matrix of features, but we're not done for the whole data preprocessing phase. And I hope you did the last necessary thing to do here in order to complete this data preprocessing phase. So according to you, what needed to be done here for this third row of importing the dataset, for this dependent variable, well, I hope that you had the right reflex and that you very simply deleted this row. Because indeed, as we explained in the previous tutorial, there is no dependent variable a priori, before we create it for the k-means algorithm. It will come later when we train the k-means model on the dataset. All right. And speaking of the dataset, well, I just like to remind that we don't have to split the dataset into a training set and a test set, because having a training set and a test set implies having a dependent variable vector. So actually here, we're all done with the data preprocessing phase. Congratulations. So now we're going to run these 2 cells to make sure everything's okay, starting with this one, importing the libraries, and now this one, importing the dataset. And everything seems to be all good. We can now move on to the next step, which will be to use the elbow method to find the optimal number of clusters, because indeed this will be absolutely necessary when training the k-means model on the dataset, because when building the k-means model, we will have to specify, well, that number of clusters we want to choose for k-means. And we will want to choose, of course, well, the optimal number of clusters. And it is the elbow method that will exactly tell us what is that optimal number. All right? So whenever you're ready for that next step, to smash that elbow method, well, join me in the next tutorial to implement this. And until then, enjoy machine learning.